everybody, welcome back. We're going to begin Unit 7, which is all about similarity. Unit 7.1 talks about dilations. We're going to talk about that right now, okay? So first of all, let's talk a little bit about similarity, just sort of a crash course. Similar figures, this little squiggly line means that figures are similar, so ABC is similar to DEF. And what that means is that all of my angles are equal and all of my sides are proportional. So I'm sure that you played with an image in Word or somewhere else where if I take this bottom corner here and I go like this and either enlarge it or shrink it, and that all stays the same, it stays proportional, it doesn't get distorted. That's like a reduction or an enlargement, okay? And that means they're still similar. If I take the side handle and I distort it, then that is not similar, right? Because it doesn't stay the same like proportion. And so that's not a similar figure. So for a similarity, all the angles must remain the same and all of my sides must remain proportional, okay? So our first little journey here with similarity is a dilation. A dilation is a type of transformation that changes the size of an image. We either have an enlargement when the size gets bigger, or we have a reduction when it gets smaller, okay? The image is similar, which means it's the same shape but different size, and the scale factor measures how much larger or how much smaller the image is. So an example here means that my CA, my segment here that connects CA, is my CA prime, is 2 times bigger than my CA. So my image CD prime is 2 times bigger than my CD. So each of these segments here is 2 times bigger, making the image 2 times bigger. So my scale factor would be 2. Okay. So how do I actually draw a dilated image? Well, if I have this triangle ABC and I want to dilate it by a scale factor of 2, which will be a reduction, we'll make it smaller, with a fixed center P. The fixed center is called the center of dilation. Our step 1 is going to be able to draw rays from our center of dilation P through the vertices of my triangle. So PB, PA, and PC. Then I will measure half of each of those segments. So PB, I'll take half of that length and put a point P prime or B prime there. I would measure PA here, and then take half of that distance and write A prime. And then I'd measure PC and take half that distance and mark it C prime. And then all I have left to do is to just connect those dots, and that would be my reduction. Okay? So let's go ahead and practice this. So here's my triangle ABC. I want to dilate it by a scale factor of 1/2 with my center being at P. Okay? So what I want to do very first of all is I want to actually go ahead and draw my rays from my center P through each of these points B. Okay? So there's my PB. I'm going to draw a ray through PA, and I'm going to draw a ray through PC. Now, when you do these, you need to make sure you use a ruler and draw these very straight, okay? I don't want any kind of sketches. They need to be done very straight, okay? Next thing I'm going to do is I'm going to measure my lengths of my sides here. So I'm going to measure from point P to point B. Right here, it's going to be about 80, so I'm going to call it 80. And so I'm going to grab my marker here and mark this here at 40 right there. Okay, that will be my B prime. Okay, then I'm going to take my ruler over here and measure it along A. And A is going to be about 60 centimeters there. And I'm going to call this at 30, half of 60, and that will be my A prime. Can't do my A there. A. Not close enough. I'll fill it in a minute. All right, then I'm going to measure along the C, which is about 92. So I'm going to call that, 46 or so. And that's A there. So 46, I'm going to put my C prime right there. Okay? Now all I have left to do is I'm going to grab my segment here, and I'm just going to finish connecting the dots here. So from my A prime to B prime, if I can get it there. I think that's it. My C prime to B prime and my, I'm sorry. I grab this guy here. C prime, and then my A prime to C prime, and there's my A prime, B prime, C prime. That is 1/2 the size of my ABC. Okay? So, right here, a dilation is written like this. So we've had our reflections and our translations. We write our dilations like this. So it'll be a dilation D, representing dilation. This will be my scale factor. So if it's 1/2 or 2 or whatever. And then around, where's my center point? C. Okay. So n is my scale factor, c is my center of dilation. If there's no center of dilation listed, then the center is going to be automatically the origin. Okay, so if I have something listed like that says dilation with a scale factor of 2, like that, that means it's going to be a scale factor of 2 around the origin. Okay, all of my angles stay congruent, but my sides are going to be, my image is going to be whatever the scale factor is times the original. Okay, my image would be whatever the scale factor times the pre-image, right? If the scale factor is greater than 1, the dilation is called an enlargement. If it's less than 1 or between 0 and 1, then it's a reduction. If it's equal to 1, of course, then it's not a dilation. It just stays the same. Okay? So a rectangle A prime, B prime, C prime, D prime is a dilation with the center P of ABCD. How are the side lengths and angle measures of ABCD related? Okay, so first of all, here's my point P, and I could go ahead and connect all those rays if I wanted to. We might as well do that. Why not? Yeah, it'll be fun. So if I take my point B, P here, and I connected all my vertices, right, all the way through here. Of course, I'd go right through here, right? That's kind of crazy, and so forth and so on. Okay, I'm not going to do all of these. I'll just kind of give you an idea of what it would look like. Comparing all my angles, notice they're all 90-degree angles, right? So all my angles have stayed the same. They're all 90-degree angles. Okay, A is congruent to A prime, B is congruent to B prime, D is congruent to D prime, and C is congruent to C prime. We're going to compare the lengths of my sides now. Okay, so I'm going to say my A prime, D prime. Gosh, I can't write very well with this thing. Let me go backwards here a minute. Go here. All right. Try this again. So my A prime, D prime compared to my AD is equal to, so my A prime, D prime is 1, 2, 3, 4, 5, 6, and my AD is equal to 2. So that's equal to 3, right? Let's compare my C prime, D prime to just CD. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 over my CD, which is 1, 2, 3, which is also equal to 3, right? Our B prime, A prime over BA is also 9 over 3 because those are the same. It's like a rectangle. Not like, it is a rectangle. And then if I compare my B prime, C prime to BC, that's also equal to 6 over 2, which is also equal to 3. So this is my scale factor right here, which is 3. So my A prime, B prime, C prime, D prime is 3 times bigger than my original A, B, C, D. Okay? So right here, if rectangle W, X, Y, Z prime is a dilation with a center P, how are the side lengths and angle measures of the two related? Of course, we know all the angles are the same. And really on these, you need to just look and see what the ratio is between my W, let's just go WZ prime to my WZ. So W prime Z prime is going to be 2 over 1, 2, 3, 4, 5, 6. And that is 1/3, right? If I look at my X prime, Y prime to my XY, X prime, Y prime is 2, and XY is 1, 2, 3, 4, 5, 6. That's also 1/3. Okay. Let's look at our YZ. So Y prime, Z prime to YZ. Y prime, Z prime is 1, and YZ is 3. Excuse me. And then our last one is going to be our X prime, W prime to XW, and that is equal to 1/3 also. So our image is going to be 1/3 of the size of our original. Okay. So here, finding a scale factor is kind of what we just did. We're going to take the length sides of our image, right? So we always take the length of the size of the image on top divided by the corresponding lengths of the pre-image. So I look right here. Here's my image right here, right? My image 18. So L prime K prime to LK. So always my image on top, okay? So that's going to be 18 over my LK, which is 12. Of course, 6 will go into 18 3 times, and 6 will go into 12 3 times. So my scale factor is 3/2. So in other words, that image is 1.5 times bigger than my pre-image JKLM. Okay, so that is how you find a scale factor. Okay, so consider this dilation here. Is the dilation an enlargement or a reduction? So let's find out what the scale factor is first of all. So let's take our A prime, B prime. So sometimes you can just pick a side. Sometimes they give you a side, and so you want to just kind of determine it from there. So A prime, B prime is 1. AB is 2. So my scale factor is 1/2. So it's between 0 and 1, which means it is a reduction. Okay. And sometimes, of course, you can just look at the image and say it's smaller than my original, so therefore it's a reduction. Okay? Okay, so you have a worksheet. Be sure to show all your work and answers, all right? If you're doing a dilation, be sure you use a ruler and make sure you draw straight lines, or I will not accept it, all right? I will see you guys hopefully soon. Have a great night. Bye-bye.